Welcome to MongoDB TV. We've got some really great content lined up for you today. Normally, we only have one live stream on Tuesdays, but today we have a special double feature. First, we're going to kick off a month-long challenge, and that is going to be centered around, drum roll, can you guess? Artificial intelligence. I know we hear all about AI this and AI that, but AI is really changing how we work, how we build applications, and how we use applications. So it's super important for us to understand these challenges and use cases, etc. So that's what we're going to talk about first. And then at 1 p.m. Eastern, Anaya Raisangani is going to be hosting the MongoDB podcast live, and she'll be joined by the CEO of Narello, Shrag Shah, and they'll discuss how his product was built and have a cool demo to show. So be sure to stick around for that one as well. Now, before we get into the main material, I want to let you know about MongoDB.local NYC. So if you're in the MongoDB or if you're in the New York area, join us on May the 2nd. And you'll hear a bunch of new announcements. You'll learn even more about how MongoDB is revolutionizing the AI industry. So use the coupon code community50 to get 50% off your tickets. And if you're not able to join us in person, we will be live streaming the keynote, as well as the rest of the day we'll be live streaming some interviews with key speakers, engineers, partners, and customers. So make sure that you don't miss out on that as well. So let's move on to the main material today. Artificial intelligence. It's just a fad, right? It's probably just going to blow over like a blockchain. Well, actually, I don't think so. It's a revolutionary change, and it's helping businesses solve real problems and making employees and individuals even more productive. So MongoDB is a document database. So how does that fit into AI, right? So it is actually it's a document database. It's also a time series database. It's many other types of databases actually, including a vector database. And so that is what sets MongoDB apart from many of the other vector databases out there. One of the main differentiators is the fact that you can store your operational data along with your vector data, so there's no need to sync data between separate databases. And this eliminates a lot of the overhead that comes with many of the bolt-on solutions that you see out there. And if you're wondering who I am, I'm Jesse Hall, Senior Developer Advocate at MongoDB. And so throughout this stream, we're going to talk about the demand for intelligent apps, practical use cases, limitations of LLMs, overcoming those limitations, some of the tech that we can use to build a smart app, and how to integrate GPT, make it smart, and optimize for the user experience. So this is all in preparation for our Rag to Riches challenge that we're going to be running all month long. That's this month, the month of April 2024. There is a link in the video description. So after this stream, you'll be able to go through this quest and build your first AI chatbot. Now, this quest is powered by Wilco, and we've teamed up with Wilco because they build amazing interactive learning courses. So I took this course, and it was fun and engaging, a very unique way to learn. So highly recommend after this to go check that out. But why should you complete this quest? Well, for one, it's free. You'll learn about AI and vector search with MongoDB. 2, you'll get a certificate of completion. And 3, by completing this quest this month, you'll get 25% off the MongoDB Associate Developer Certification exam. So with this exam, you can become MongoDB certified. And on top of that, you can get another 50% off of that exam if you take our free MongoDB Node.js developer path. So by completing the Rag to Riches quest and the Node.js developer learning path, you'll get a total of 75% off of that exam. So you might be asking, why Node.js? Well, it's true that a lot of AI developers use Python, and that's great for data analysis. But when it comes to integrating AI into your applications, especially web applications, you might find it easier to have your entire stack written in JavaScript or TypeScript. So our Rag to Riches challenge and our open source chatbot framework, which we're going to talk about a little bit later, are Node.js based. And so let's get into preparing you for these. The rest of the stream is going to be an introduction to AI and RAG, retrieval augmented generation, why it's essential to a great user experience in your applications. So there is a huge demand for building intelligence into your applications in order to make these modern, highly engaging applications and making differentiating experiences for each of our users. So you could use it for fraud detection, for chatbots, personalized recommendations, and so on. To compete and win, we need to make our applications smarter and surface insights faster. The smarter our apps are, these smarter apps they use AI powered models to take action autonomously for our users. And then the results are twofold. First, your apps will drive competitive advantage by deepening user engagement and satisfaction as they interact with your application. And secondly, your apps will unlock higher efficiency and profitability by making intelligent decisions faster on fresher, more accurate data. And so almost every application going forward is going to use AI in some capacity. And so in order to stay competitive, we need to build intelligence into our applications in order to gain these rich insights from our data. So AI is being used for both powering the user-facing aspects and utilized on those fresh insights, the fresh data on the back end as well, to help us to make better business decisions. So there are a lot of use cases, and here's just a few here: retail, healthcare, finance, manufacturing. Although these are very different use cases, they're all unified in their critical need to work on the freshest data in order to achieve their objectives in real time. They all consist of AI-powered apps that drive the user-facing experience and predictive insights, making use again of that fresh data to automate and drive more efficient business processes. But let's take a look at the evolution of AI. Where did we come from and how did we get here? So we started out with analytics. And so in the early days of computing, applications primarily relied on analytics to make sense of data. Now, this involved analyzing large data sets and extracting insights that could inform business decisions. And as computing power increased, it became easier to analyze larger data sets in less time. And so next came batch AI. So as computing power continued to increase, the focus shifted towards machine learning. Traditional batch machine learning involves training models on historic data and using them to make predictions or inferences about future events, about how your users might interact in the future. So the more data over time that you feed your model, the better it gets, and the more you can tune it, and the more accurate these future predictions become. And so, as you can imagine, this is really powerful because you can predict what's going to happen tomorrow. If we can do that, we can make some really great business decisions today. And so, batch AI, as the name implies, is usually run offline on a schedule. And so, it's analyzing historic data to make predictions about future events. And that is kind of where the problem is with this specific type of AI. It's working on historic data and it can't react to events that happen quickly in real time. Now, this could still be beneficial for certain industries and certain use cases, but we need data on things that are happening now. And so this is where real time AI comes in. So, real time AI represents a significant step forward. This approach involves training models on live data and using them to make predictions or inferences in real time. Now, this is particularly useful for fraud detection, for instance, where decisions need to be made quickly based on what's happening in real time. I mean, what good is fraud detection if the person defrauding you has already gotten away with it, right? And so, next up is generative AI. And so, generative AI really represents the cutting edge as we know it today. And this could change tomorrow, who knows? But this approach involves training models to generate new content. This could be images, text, music, video. And it's not simply predicting future events anymore, it's creating the future. And the fun fact here is all of these images here were created using DALL-E. And so over the years, we've seen AI evolve from analytics to real-time machine learning and now generative AI. And these are not incremental changes. Each one of these were transformative in their own way. They shape how we interact with technology every single day. So, you've probably heard of something called generative pre-trained transformers, or GPTs. These are large language models that perform a variety of tasks from natural language processing to content generation, and even some elements of common sense reasoning. They are kind of like the brains that make our applications smarter. But there's a catch to these. These GPTs are incredible, but they aren't perfect. One of their key limitations is their static knowledge base. They only know what they've been trained on. And there are some integrations now with some models that can search the internet for newer information. But how do we know that that information that they're finding is on the internet is accurate? They can hallucinate as well, very confidently. So how can we minimize this? They can't access or learn from real-time proprietary data either, your data. And that's a big limitation, don't you think? The need for real-time proprietary domain-specific data is why we can't rely just on LLMs as they are. And this is especially true in the business context where up-to-date information can be a game changer. And so, what's the solution here? How do we make these models adaptable, real time, more aligned with our specific needs? Well, this brings us to the focus of this stream today. It's not merely about leveraging the power of GPTs, it's about taking your applications to the next level by making them intelligent and content or context aware. We're going to explore how to augment applications with smarter capabilities using large language models and then boosting those capabilities even further with retrieval augmented generation, or RAG. And so we're not just integrating AI into our applications, we're optimizing it to be as smart and context aware as possible. So, what is involved in retrieval augmented generation? First up, vectors. What are vectors? So these are the building blocks that allow us to represent complex multidimensional data in a format that's easier to manipulate and understand. So the simplest way to explain this is a vector is a numerical representation of data. And even more simple, it's an array of numbers. So these numbers here, a quick brown fox, the embedding or the vectors of that is just an array of numbers. And these numbers, oops, go forward. These numbers are coordinates in an n-dimensional space, where n is the array length. So however many numbers we have in the array is how many dimensions we have. You also might hear vectors referred to as vector embeddings or just embeddings. So here is a real life example of vectors in use. So when you go to a store and you ask a worker where to find something, many times they'll say, go to aisle 30, bay 15. So that is a two-dimensional vector. You'll also notice in the store that similar items will be placed near each other for ease of searching and finding. For instance, the light bulbs, they're not scattered all over the store. They're specifically placed to be easy to find. Another example is in games. Games use 2D and 3D coordinates where to keep track of objects in a game's world. And these coordinates can be used to compute proximity between objects for collision detection, for instance. So the same kind of math is used to compute the similarity between vectors during vector search. And if you're a Stargate fan, the gate addresses are made up of at least 7 dimensions, which are like vectors. And to locate stargates in other galaxies, you add an 8th or a 9th dimension. And just like you would a phone's area code or country code. And so this really shows how adding dimensions significantly increases the size of the virtual space in which our data is organized. So again, what makes vectors so special? They enable semantic search. In simpler terms, they let us find information that is contextually relevant and not just a keyword search. And the data source is not limited to just text. It can be images, video, audio, and these can all be converted to vectors. And so how do we go about creating these vectors? Well, this is done through an encoder. The encoder defines how the information is organized in this virtual space. There are different types of encoders that can be used to organize these vectors in different ways, depending on your use case. There are encoders for text, for audio, for images, and so on. And so the majority of the popular encoders are accessed through Hugging Face, OpenAI, and many others. So now let's tie all of this back to retrieval augmented generation. RAG leverages vectors to pull in real-time context relevant data to augment the capabilities of the LLM. Vector search capabilities can augment performance and accuracy of GPTs by providing a memory or ground truth to reduce hallucinations, providing up-to-date information, and allowing access to private data. So first, we have our private data, our custom data, whatever that might be, and we use or we generate our embeddings using the embedding model, and then store those embeddings in the vector database. So again, this data can be documents from our site, blog articles, videos, images, etc., PDFs. And so in this example here, we have LangChain facilitating all of this. It's very helpful. There are many other ways to go about this. You could write it yourself, but LangChain is actually very helpful, very useful. And so we have that orchestrating everything here in this diagram. So once we have our embeddings in our vector database, we're now able to accept user queries to find relevant information within our custom data. So to do this, we send the user's natural language query to an LLM, which vectorizes their query. And then we use vector search to find the information that's closely related, semantically related to that user's query, and then return those results. And then we can do anything that we want with those results. We can summarize the answer to their question based on our custom data. We could respond with links to specific documentation pages and so on. So imagine your application has an intelligent chatbot, and with RAG and vector embeddings, this chatbot can pull in real-time data, maybe the latest product inventory, and then offer it during a customer service interaction. So with RAG and vector search or vector embeddings, your application isn't just smart, it's adaptable, real-time, and incredibly context-aware because it has that extra information. So now again, you can have an advantage by using MongoDB because not only do you have your vector store, but you also have your operational store, which has even more metadata that can be used to enrich your queries. So this is something that we built at MongoDB with this same architecture. This is the MongoDB documentation website. We have a MongoDB AI chatbot that allows you to ask questions about MongoDB, and it only responds with answers from our own documentation and other internal resources. So the question here is, how do I get started with MongoDB and Node.js? And it answers us with a summary and some links to specific pages in the documentation and other resources to help us further. We also have some more learnings. If you want to do a deep dive into how we built this, there is a podcast episode as well as a blog post from Ben Perlmutter. And this talks about how we actually built this chatbot. You can check those out. There's links in the video description below. And so all of this has resulted in our open sourcing a chatbot framework that you can use in your next application. So this framework comes with several pieces: an ingest CLI, which helps you to ingest whatever data you want to embed and store in your vector database. It also comes with the chatbot server, which is the backend. It's basically the brains. It controls the vector search and the queries from your users, and that is built on Node.js. And then the chatbot UI is the front end, and it's built in React, so that accepts the user queries from the front end. And then we have an evaluation CLI in this framework as well for testing before you deploy to production. So you can go check that out at GitHub /MongoDB/chatbot. Again, it's open source, and you can use that in your next project. But what is next? So next, go complete the Rag to Riches quest and build your first AI chatbot powered by MongoDB. Again, there's a link in the description. And then after that, book your calendars. April 18th, Ben Perlmutter is going to be back on, And we're going to have another live stream where he's going to walk us through using that open source chatbot framework in a real application. And then we're going to go into some question and answers as well to help you out. So again, go back and complete that rag to riches quest, and then it's very informative. It's actually a very fun quest to go through. I think you'll definitely enjoy it. And so this is the end of the slides here, and I want to leave a little bit of time for some question and answer. So let me go back and look at the chat and see if there are any questions. Um, I'm not seeing any questions right off the bat. So again, go check out the Rag to Riches quest. That looks like there is a question that came in. Rather than doing the attribution at the end of the response, how do LLMs do inline attribution? I think maybe you're talking about the RAG architecture. And so basically, what we do is inject our custom data before actually going to the LLM. So we do a vector search, we find relevant data, we enrich the question, then send it to the LLM, and it comes back. And you'll learn a lot more about that through the RAG to Riches quest. And then again on the 18th, come back and we'll see it in real life. We'll build an application and with this architecture and leave some time for questions at the end of there as well. All right. Yes. Thank you. Thank you, Alexandro, for that. I like analogies. I try to make things simple and easy to understand. All right, so that's going to be the end of today's stream. Remember, at 1 p.m. Eastern, we have the MongoDB podcast live with Anaya Raisingani. She has a special guest, so be sure to come back for that. And we'll see you next time. Thank you all.